We'll continue some work in this lesson on some circle stuff, arc length and area of a sector. You'll be able to determine the arc length and area of a sector of a circle when given its radius and central angle, or arc measure. We'll start with arc length. Arc length is a piece of the circumference of a circle. You know, the circumference is all the way around the circle. We're going to look at a piece of it, or what's called its arc length. Maybe this length from here to here, this piece of the circle. The way we're going to find this arc length is, again, it is a piece or a fraction of the whole circumference, the whole distance around the circle. So you can see our formula here. We have a fraction times 2 pi r, which is the circumference. That's how you find a fraction of something. Just take a fraction times it. So the question is, how do we get this one thing we need to know here? Of course, r and this circumference is the radius. But what is this x degrees? And we're always dividing it by 360. The x degrees is the measure of this arc or this central angle. Again, we learned earlier that the central angle equals the measure of its intercepted arc. So these are the same, either one of these, you know. If they give us the angle, we know that measure goes up here in this formula, or the measure of the arc that goes up here. That gives us a fraction of the whole circle. How many degrees out of the 360 degrees the whole circle? So let's take a look at an example. Here's find the length of arc LM. Here's LM. So let's see, they don't show me how many degrees this central angle or this arc is, but the major arc on this side is 300 degrees. So that leaves us 60 degrees for this arc right here, LM. You can put it in your picture if you want. This would be 60. So then they got 60 plus 300, there's 360. So now we're ready to do our formula here, which says the length of this arc will equal the measure in degrees divided by 360 times the circumference, 2 pi r. So we just substitute the 60 in there. And then I'm using these stars for times 2 times pi times the radius. The radius of this circle is 3. And so you can put it in your calculator just like that. 60 divided by 360 times 2 times pi times 3, and round to the nearest tenth like we always do. And we get approximately 3.1. You know, if this was, they don't give us any units. If this was inches, that would be 3.1 inches around there. It's a little bit bigger than the radius itself. So that's all there is to it with this formula. The measure of the arc divided by 360, there's our fraction of the whole circumference, 2 pi r. So why don't you pause the video and do the quick check. See if you get the right answer in a minute. I'll do it. Pause it now and give it a try. Use the formula. It's not too tough. Well, hopefully you paused it, and we'll check your answer here now. So we can see from this picture the central angle is 120, and so the arc is also 120 degrees. We put that up here, the measure of arc EF, 120 divided by 360, the whole circle, times the circumference, 2 times pi times the radius, which is 6 right here. Put that all in our calculator, we get approximately 12.6 rounded to the nearest tenth. Now we'll look at a different type of problem, what's called the area of a sector. A sector is a piece of the area. It says it's a slice of the circle bounded by 2 radii. Here's a radius right here, here's a radius right here, here's our 2 radii it's bounded by, and the arc right here. So they're looking at this area right here. Well, the area of a sector is a fraction of the whole area of the circle. So it's similar to our arc length, where we're taking a fraction of the whole circumference. Here we're taking a fraction of the whole area of the circle. Remember, area was pi times the radius squared. And here's our fraction again, and we realize this is the same fraction we had in the other problem. It is how many degrees the arc is divided by 360, a fraction of the whole circle, times, again, the area formula. So these are very easy to, setting up the same type of formula. So what do we have here? We're going to find the area of the sector below in example 2. So we can see it shaded. So we can see the arc measure is 20 degrees and the radius is 3. So again, by the formula, we're going to take the measure of that arc, or central angle, 20 degrees, divided by 360, and then take it times the area formula, not the circumference formula. Pi times the radius to the second power. So again, we can put that in our calculator, check it, do it with your calculator, and see if you get the same answer as me. Round it to the nearest tenth. I have 1.6 approximately. Pretty small because, again, this is a pretty small fraction of the circle, only 20 out of the 360 degrees. Here, go ahead and try the quick check. And then pause this video, try it, see if we come out the same answer. Alright, let's check it. Alright, we got 120 degrees with this central angle, so this arc is 120 degrees. And we'll find the area, so we take the measure of the arc divided by 360 times the area, pi, times the radius squared. The radius was 6 squared. Put that into our calculator and round to the nearest tenth. I have 37.7. Not too bad. It's an interesting concept, not too tough to do. You think of it as a fraction of the whole circle, whether it be area or circumference. Let's see, a couple more right here. Here we go. We're not going to find the exact one. Example 3, let's just find and round to do a couple more examples with just rounding to the nearest tenth. So go ahead and cross that out. Go ahead and try it. We're going to do the area of the sector, the length of arc AB, and the area of the sector. I'd pause this video and see if you can find me those two answers. So hopefully you paused it, found these two, round to the nearest tenth. Let's take a look here. So we don't have this arc measure, so we got to look around here. Okay, this side, this arc is 210 degrees. So if we take 360 minus the 210 and get what's left, this arc would be 150 degrees. Double check. Let's see, 210 plus 150, yes, it's 360. So we're ready to find our area of the sector and the length of the arc AB. So we take how many degrees that arc is, the measure of the arc, 150 divided by 360. For length, we're taking the circumference, 2 times pi times the radius. And that is approximately 13.1 for the length of this arc, how long it is. The area still have the same central angle or same measure of the arc, 150 degrees. This times the area, pi, times the radius squared, which is approximately 32.7. Go ahead and try this quick check. Pause it, try one more example, then you'll do your practice on your own. Alright, let's check this problem. We'll find the length of this arc and the area of this sector. You can see it's got 30 degrees for the measure of the arc and a 6-inch radius. So our degrees goes right here for the length. And then times the circumference formula, 2 times pi times the radius, 6. and that's approximately 3.1. Now the area, still start with the same fraction. So the same fraction of the circle, 30 degrees out of 360. Then times the area, pi times the radius squared, which is approximately 9.4. Okay, not too tough. A fraction of the whole circumference for length. A fraction of the whole area for area of the sector. How do we get the fraction? Measure of the arc or central angle divided by 360, the whole circle. Alrighty, work on your practice problems now and you'll be finished. Good work.